Okay, so I wanted to go over the first experiment that you guys turned in, which deals with experimental uncertainty. And I want to kind of focus in mainly on this part that usually causes a little bit of hiccups with students. So zoom in here. I have a couple graphs on the screen. And so the first one that you were to graph was, first you were to plot some points. And the key here is that you need to recognize the general form of a parabola. So the general form of a parabola looks like y is equal to at squared or ax squared, whatever the variable is. And you can kind of see it kind of takes on the shape here as a parabola does. And so you were to plot that, make sure that when you plot these things and you give them to me, you give the right units. You describe what that variable is. You always want to assume that the reader doesn't know what you're talking about. And then we were to plot y bar versus t. Let me move that over a little bit so you can see that. And so y bar versus t, if we were to plot this, looks something like this. Now, one of the things that you guys may have done was you may not have created your graph such that the axes are, if you will, proportional. So I saw on some of you guys' papers where the axes were a little bit smushed up. And so, kind of take a little bit of time and see if it is what you want. In this case, remember, we're trying to force this to be aligned. We're using linear regression here. And so by doing that and plotting these points, now see, I'm doing this by hand. And again, you're going to want to do this using a computer or maybe Excel. Excel is probably the easiest and most accessible. Don't always trust what Excel says, because a lot of times it'll give you formats such that they are, in the shape that maybe you have the settings at. So just be careful, know what a graph versus a line looks like. So a line is going to have a form y bar or y equals mx plus b, right? So instead I wrote y equals ax. I didn't want to use m because in physics we use m a lot for mass, meters, and I've already used well, meters in this problem. So I just wanted to switch it up just a little bit. So if we plot y bar versus t squared, we treat t squared as a single variable, and that single variable is that x. And so we're kind of forcing our way into this line. So we're saying we're going to force this to be a line. We're going to regress and push all these numbers or these plots so that they make a line. Now, I didn't put a whole lot of plots on here, a lot of points on here. And again, it's not the most accurate, as I said before. And that's what's going to happen a lot in physics and experiments. You're not going to get everything perfectly right, especially if I'm doing this by hand. So moving on over here, you can see that if we're thinking of it in the form of y bar equals ax, a now becomes our slope. And now we pick off 2 points from this graph, y bar versus t squared. And I picked off, typically you want to pick some points that are not outliers. So these points are probably outliers. I could have probably used 0, 0, because that's a known. When I put my little straight edge here, my ruler, it didn't show up very well. So I just decided to do that. So, and so now I just find the slope of this line. The slope of this line turned out to be, for me, about 4.8. And the units are, notice here, meters per second squared. That's going to be a point of emphasis throughout the semester. And so now, if I go back, we'll we'll circle back to the first equation that we talked about. This A is gonna match up in a second when we go back to the 1/2 G, 1/2 G. So if we look back over here, this is the same A as what I just solved for. And so by solving this for G, I would multiply both sides by 2. All right, clears the fraction and gets G isolated. And now I see that G experimentally by my standards here turned out to be 9.6 meters per second squared. And we know that the acceleration due to gravity, typically standard number is 9.8 meters per second squared. So that's in the range and it seems reasonable. So linear regression is something that you're going to do throughout the semester. So kind of take a look at it, make sure you make corrections on your paper. And if you have any questions, feel free to give me a call or send me an email. Take care.